Hey everyone, nice to be with you. My name is Catherine LaChapelle. I am a sales engineer here with Looker, which is now part of Google. I'm based in the New York office, and today I will be walking you through how you can leverage Looker and BigQuery together to address some of the complex challenges that you're facing in retail. So first, I've got a couple things I want to talk to you about today. I want to talk about how we can leverage the unique blend of Google capabilities with Looker for visualization and a data platform to detect potentially fraudulent orders. We're going to walk through how you can actually do customer segmentation to better understand who your customers are and what their purchasing behavior is, so that you can really tailor your messaging to them and your interactions with them, all without leaving Looker. You actually are able to build those models and visualize them from BQML. And finally, I'm going to talk to you about some of the unique native third-party data integrations between Looker and Looker and BigQuery that you can leverage to make more informed decisions about your business. Before we get to all of that, I just wanted to address how you can do some basic cost control between Looker and BigQuery. As you may recall, the Looker architecture is unique in that we run 100% in your database, which means that what Looker is doing is it is generating the SQL queries for you, but sending those to your database, BigQuery in this instance, to actually execute the queries and returns the result set back to Looker. Keeping that in mind, we want to make sure that we're maintaining visibility and control over the queries that we're pushing to the database, just so that we can have a good picture on our consumption and billing. So a few ways that we make that happen with this partnership is with query caching. So what you're able to do is set a caching policies in your models in Looker so that depending on what your business requirements are and how long you want to cache data, you actually can store that, the result set in Looker, so that you're not hitting the database every time you want to reload a dashboard within a certain period of time that you define. And that means that your users can all interact with it without necessarily pinging your BigQuery database every time. As an admin, you have the ability to put in cost caps on your query, as well as to provide transparency into the query costs so that a user can see what the expense will be before they submit the query through Looker to BigQuery. We also have things like pre-aggregation, partitioning, and sharding for performance. By dividing a large table into smaller partitions, you are able to improve the query performance. And another benefit is that you can also control the costs by reducing the number of bytes read by a query. We also have persistent derived tables so that you can, if say you want to change the aggregation level or structure of a table in your underlying database, maybe roll something up from the order items level to the order level, you can use persistent derived tables to actually write that back to your database, to the Scratch schema, and persist it for a given period of time so that it's not re-executed every time a user wants to interact with some data element that pulls from that table. We also have aggregate awareness, and aggregate awareness allows Looker to understand when there are multiple tables with different levels of aggregation, which one is the most appropriate for a query before executing that query. And what that means is, say you have a granular order level detail and you have something that's rolled up to a higher level, maybe at the user level. If what you need is only information at the user level instead of the order level, we can actually go at the higher level table and thus process less data and keep your costs down. We also have a Looker block for BigQuery optimization. And this allows you to have transparency into things like what's the query size that you're doing, and what are the costs associated with it, to really start to understand and uncover trends and patterns so that you can have a really good sense of what's happening in the business with the data, as well as how to kind of manage the expenses along with it. Now let's get to the retail specifics. So there are three main topics we want to talk about today: fraud detection, customer segmentation, and native data integration. All of these are specific to how you can best maximize using your technology suite of using both Looker and BigQuery together. So with fraud detection, I'm going to show you an example of using Google Maps search, specifically Street View, to identify a fraudulent address where essentially what's happening is somebody's ordering a large amount of items to go specifically to a self-storage unit and then resell it from there, thus degrading our brand value and market presence. Really easy to implement and catch these kinds of things with a Looker and BigQuery integration. That's the kind of thing that would be really hard to catch manually without using all of these tools in an integrated manner. We're also going to talk about customer segmentation. So we're going to do some clustering and statistical modeling, my favorite, to help identify who are our customers and really use the statistical models to group them together so that we can really identify who they are, what they have in common, and what they each want. And that way we can really drive targeted marketing campaigns towards our customers in a manner that feels highly personalized and effective to them, to really improve that brand engagement and awareness that they have with us. Finally, we'll talk about native data source integration. So by using BigQuery, you have access to a ton of different public data sets that BigQuery publishes and makes available for you. By blending that with your proprietary business data, you're able to unlock new insights in a really simple, straightforward way to help you make better data-driven decisions about your organization. It's an extensive set of over 130 publicly available data sources. And we'll go through some of those in a little more detail. All right, so with that, let's hop into the demo. So I'm landing here at this retail dashboard. This is for a fictitious apparel company called Fashionista. You can see their logo here. This dashboard is a kind of a high-level landing page. You can think of this as maybe like a VP of merchandising or really anybody else at the company who wants to have a pulse on how the business is performing. We'll see a couple things at the top here, like I'm 91% of my target over the past 7 days. So you can see how you're tracking. I can see that my transactions from my folks in my loyalty program are actually down compared to last year. So something to keep an eye on. You know, I'm still around the industry average of 50%, but I certainly don't like that it's trending down. One thing that I can do is I can actually set an alert on this. And so let's say, you know, maybe I want to keep a pulse on it and say, if it drops below that 50%, alert me or other folks in my organization, send me an email. You can choose the cadence. And that way you can really stay on top of this and lower the barrier to entry, right? So I don't have to log into this dashboard every day necessarily just to check this. I can kind of let Looker handle that for me. You can also see how I'm trending year over year. You'll see that this month is a little bit low. That's because we just started June. But the good news is that overall, it looks like I'm increasing year over year, and that 2020 is off to a relatively good start for me. Looks like I have some stores spread out across the country. let's start to drill into, how each of these stores are doing. So here's the full picture here of the change in each store in the sales volume that they have relative to last year. So one thing I'll notice, let's pick on Phoenix, for example. It looks like Phoenix isn't doing as well as they did the previous year. For example, they're down 15.5%. They don't want to take action on that though. One thing you can do is actually use our Action Hub to build in custom integrations to use other applications to actually do things like messaging directly from the Looker platform. So for example, maybe I want to reach out directly and text the store manager for Phoenix. And so instead of leaving the Looker platform and going and finding their contact information and sending them something and telling them to go look at it, I can actually just do it directly from here and even reference this dashboard where I found this information so that we can all immediately be on the same page. Now let's start to look at the customer segments. So you'll see over here, I have the description of my 4 segments. I have emerging millennials, my regular Gen Xers, affluent retirees, and one-off locals. Although these segments are named based on kind of an age grouping, they're actually defined by a statistical model. This is a k-means clustering model in this particular example. And we've just used these as sort of descriptive categories based on the behaviors that we see and the demographics that we see across these groups. By doing it this way, we really allow the data to tell us what's happening, tell us who is like each other based on the metrics that we care about, based on the things like how much they're spending, what their purchase behavior is. And by really understanding who those folks are and what their patterns are, we're able to create really targeted messaging to help engage them in our brand. We can also see things like, for example, the cohorts of the different segments and how they are performing over time. For example, it looks like my emerging millennials here, the emerging millennials in this pink color, it looks like they kind of drop off a little, especially around maybe the 8-month mark, whereas at the 8-month mark, the regular Gen Xers make a comeback. Maybe we want to understand a little bit more about who those emerging millennials are. I can actually drill directly into another dashboard specific to the emerging millennials and get a fuller picture of who those folks are. Now, the way that I created this customer segment deep dive is with leveraging BQML. So BQML is within SQL, written against your BigQuery database. And what it allows you to do is write and create statistical models directly in your database within SQL statements. So it brings the power of statistical and predictive modeling into SQL and into your database directly without having to move it into another tool. Now, the way that we do this is we invoke the create model statement. I encourage you to go find the documentation for it online. It's very helpful and extensive. But at a high level, it offers things like linear and logistic regression. So predicting something based on predicting either a categorical or continuous response. K-means clustering, which is what we're using here, which uses different data points to figure out how they group together. Matrix factorization, which is really cool. That one is for recommendation systems. So say figuring out, if you purchase this item or you have this item in your cart, what other items do people tend to purchase with it? And finally, the one that really opens the door for everything is the ability to directly import a TensorFlow model. So TensorFlow is an open source technology. It's essentially a library within Python published by Google, where you can create more complex machine learning models, and then you can import them directly in BQML. So really, you have a ton of different options by leveraging the BQML, BigQuery, and Looker. So diving into these millennials a little bit, we can see that they're really on the rise in terms of purchases with our company. So they're up 1,128% compared to last year, which is a great trend. It seems like all of these KPIs are pretty high. But what we do have is a customer reactivation campaign. So specific to this segment, we've identified some folks who have dropped off from purchasing with us over the past year. And we want to re-engage those, especially because we see that they hold a lot of value for us. So what we can do is actually create a reactivation campaign directly from this environment. And I see here that if we were to capture just 10% of the customers identified from this list, that would potentially, that could lead us to $2,132 in immediate value. So definitely worth looking into. And we can actually just create a campaign segment directly here. Click this link, send it to our CRM platform, and start trying to get some of these customers to re-engage with us. All right, so that's our overview dashboard. Now let's start to do a few deep dives. So let's start looking at the store level. We picked on Phoenix a little before, so now let's look at Los Angeles. This is a really easy way to do kind of some cohort comparing. So how does Los Angeles compare to its peer stores? Now, one thing I noticed is that my percent of transactions that are coming from loyalty customers, again, it's still down compared to last year, but it's down compared to last year, and it's also a little bit behind kind of where the overall was. So that might be something we want to drill into a little bit. Overall, it looks like we're tracking pretty close to our target, again, for the past week. And this is a filter I can edit if I'd like to change the number of days or the store location, but it looks like we're doing all right so far, relatively speaking, compared to our target. But let's see how our year-over-year sales compare. So it looks like the Los Angeles store is actually down a little bit compared to last year. And one thing that we can do here using BigQuery together with Looker is check out to see what role, if any, weather has to play in that. So this is where the publicly available data sets come in. You see I have the weather trends data published here. That's going to be the purple line on this plot. That's the average max temperature, again, over the past 7 days. And the black line is my total sales per store. So what I'm doing is I'm accessing the publicly available BigQuery data sets along with my proprietary business data sets, combining them together in this query and seamlessly analyzing these two different data sets together. And so what I can notice is that it looks like for the first few days, these were kind of tracking together, but then maybe around May 28th, there was kind of a big spike where there was a bit of a divergence. So we might want to look into that to see kind of what was happening in the area and what trends we might be able to see, as well as look at forecasting for the weather and what impact we think that might have on our stores. So this native integration with third-party data sets, we've looked a little bit about the weather data here. That comes from NOAA. You can use that for model predictions as well, and visualizing the weather predictions and conditions across the stores. There's also an extensive data set. It's over 130 publicly available data sources. These are backed by some pretty big players like NASA, GitHub, the census. That one's pretty cool. You could think about using census information to figure out localization of who your customers are in a given area and how you can target selling, interacting with them in a really specific manner based on, kind of who's your customer base in a given region. And many, many more. So I encourage you to take a look. Again, publicly searchable. the BigQuery data sets that you have access to and can blend with your proprietary data. So now that we have a solid understanding of how the weather's been working, let's look specifically at, maybe let's start to look at the addresses to which I'm sending some of my products. So for example, I have this address deep dive dashboard. This is the use case I was talking about at the beginning, where we're actually identifying some fraudulent transactions. So what we noticed is that we actually had a large number of orders going to one particular address, and we started to see some leakage where things were popping up by resellers in regions where we don't actually, where we're not actually selling. And so of course we want to protect our brand identity and catch these kinds of orders before they're being resold too much in the gray market. So by using a custom Google search, we're able to actually integrate directly with Google Maps to get a street view and identify the locations to which we're shipping our orders. And by doing that, we realized that we have 21 registered customers at this address that looks like a self-storage unit. There probably aren't actually 21 people living there. And it seems more like an operation where folks are actually just using that to receive packages and then resell it from there. And we can dig a little bit deeper and understand what they're ordering. It seems like there's a lot of interest in this particular suit. This is actually what kind of tipped us off. We were seeing this being sold on third-party websites. And so by doing this, by using the combination of seeing the ordering patterns, what's being ordered, and the street view, we were able to make a decision that these are not legitimate transactions, and actually, once again, set an alert to send it to our fraud department so that they're able to investigate and make sure that we're selling to legitimate customers. That's enabled by the Google search, the integration with Google Maps to search for the street view. But you'll also notice that on this page, we have the product images. So these product images are not actually living in my database. These are using a custom Google search function that is actually using the product name here to go out, scan the web, and pull the product image directly in here. What that allows us to do is really bring to life the data sets that I have here so that my end users, be it somebody who's in charge of merchandising or detecting fraud like this, or even at the store level, a sales clerk on the floor who's looking up different order items, for example, to really interact with this and not just look at a row of data, but have a visualization for what the products are that we're talking about, really bringing it to life.